Okay, next up, I want to look at containers, but real quick before we do that, before the break, I very quickly uh, tried to pull up an example using Flask and had to enter the environment variables. And I suddenly remembered that that video that is in your homework has Mac specific instructions for that part. And it might have confused people that aren't using a Mac. And I quickly typed it in, but let me go over that real quick for other terminals. Um, let's see. I open this. What all do I have on here? Let me turn on some sort of Linux machine. On there, WSL dash dash. Great. That should be good. I have to go to the store. Install. Why is it not giving me Ubuntu? Okay, there we go. Oh, I was expecting that one to happen in like a couple of seconds. So it appears it's going to take a minute. So that's down. Um, so uh, I'll use git bash. That So this is what was in that video. If you watch the Flask video, whenever they go to make the variables for Flask, they just set a variable. So in that video, he types the word export, then Flask, Flask underscore app equals, I don't know, whatever you called it, my app.py. And we just say where that is. And then there's a second one in the video that was removed several years ago. I can't remember what the other variable is, but we don't need it anymore. But it's kind of the same thing. You use export to set a variable in Bash or Z or if you're on a Mac, like he was doing in that video, which is Ubuntu, but it's currently not installed on my machine. So for PowerShell and command prompt, it's a little bit different. So command prompt's really close. I'll look at that one first. If you use command prompt, though, if you weren't already aware, command prompt or CMD doesn't actually do anything anymore. That was removed in 2014. But when they removed it, people people freaked out. They removed it because PowerShell was fully debugged and PowerShell accepts all the old commands. So people freaked out when Microsoft removed it. So what they did is put back in this basically text editor that forwards the old commands to PowerShell. So you can type all of the old commands right in PowerShell, and this one doesn't actually have access to run your computer anymore. It just forwards it to power. It just forwards instructions to PowerShell. But it made people stop complaining when they put it in there. So, but you can also type all the old instructions right in PowerShell. So in that video, he uses export and then the variable name because he's doing it on a Mac, and on the old instruction on command prompt was set. So you would want to do set Flask underscore app equals Flask app.py or whatever you call the app. Names are relative. So change that word export to set if you use command prompt, which will work in PowerShell because all command prompt does is forward things to PowerShell. The PowerShell syntax, variables always start with a $sign. So Like we just put a dollar sign, then the name of a variable and an assignment. So for the environment variables, type dollar env. This is what I did a moment ago. And then flask app equals, and it has to be assigned a string at this point. If you don't assign it as a string, PowerShell defaults to objects, not to strings. That's why it's a loosely typed language. That's why we have dollar signs. But if we don't explicitly put quote marks and say that it's a string name of a script, some script with API.py, if we don't explicitly put the string, PowerShell will notice that it's a py script and try to change it into a Python object for us automatically. But in this case, we just want the file path. We just want the name of the file. And same thing for that other variable that I can't remember the name of. It's mentioned in the video. Either export or set an environment variable, and then that might be Flask environment. Anybody watch that video yet? Do the weekly homework. If that's the name of whatever the name of the other variable is, that was removed a couple years ago, but it's in that video. So if you're in PowerShell, that's how you would set those variables. Relation. Why is this going so slow? And prompt, you would just use the set keyword, and oh, there we go. Once this goes back to a prompt, there we go. Once I get back to a bash prompt here, if you're in bash, like that's what he was using in the video, the keyword is export to create a variable. So that is slightly different in all of our terminals. I remembered like the last 3 or 4 times I taught the class to send out a video about that, and I forgot that last week. So I apologize for that. And I did just kind of had suddenly throw it out a few moments ago, and then afterwards realize, oh wait, I didn't send them a video telling them what I was doing with that, which is kind of an important part. Everybody get that? Or take note of where to reference that when you, if you haven't done that homework yet and you're going to do it after class. So next thing on the list, we wanted to talk about Docker containers. Actually, I'm going to write containers. There's a modern way of releasing applications. That gives the developer control over configurations. Obviously, that's not very, that's kind of some small writing for you all to read off the board there, isn't it? Amen. There we go. So the main idea with a container is it's a way of releasing our software where we have control over all the configuration files. Obviously, that's not the technical definition. You can look up the technical definition for that. That's a very, very easy search. The most popular one is Docker, or one of the most popular ones. Let me draw a picture here. So somewhere out in the world, we have this end user, and they have their computer. I'll just draw it like a laptop. And over here, we have our software, which is going to be made up of a bunch of files and resources, right? All of the scripts it takes to make up our file. Since we're in Python, we're going to send them the Python scripts directly. But in other languages, we might compile it first and send them the compiled DLLs or something. But over here, we have our software. And traditionally, we would put a version number on it. I'm just going to make something up here. So maybe we're up to version 3, release 7, patch number 8. Right? It's the third major overhaul of our software. And there have been 7 significant updates and 8 little patches along the way. So every time we find a bug and have to fix it, we need to go through here. Well, first off, we have to get our software onto that user's computer, right? So that's where the traditional installer comes in. We make an installer, give them this version, and then at some point later, we find another bug. It's a quick one, so it's only a little patch number on the end. And we need to now get version 3.7.9 onto that user's computer. We're going to need their permission to do that, right? That whole check for updates, or maybe just send them a notification. There's an update available. Do you want to install it? We really trust this user over here to click yes, that they need to install this, or the latest version, the one with all the bugs that we know about fixed. It's a good chance that user is going to keep ignoring that update button and then start complaining when they encounter one of those bugs. Or worse, this user probably has admin privileges on their computer. So our software depends on all of these files that we copy and paste onto their computer. So what happens if they start messing with those? Go in and see files that they don't know the name of and start deleting them. It's going to cause our software to crash. We lose control once we give them those files. An installer is just a really fancy copy and paste. So what a container is, sort of the next step up, instead of just giving them these files, I'll use blue, hopefully that's showing up. What we do is we make a small virtual machine. We make a little bitty virtual machine that doesn't do anything except run our software. That's a container. I need to write bigger. And over here so that it's on the board. And in that case, like this obviously isn't a technical definition. This is what we as software developers want from a container. There's other advantages we get, but now we have access to all the configuration files. So we don't have to worry about the user messing with any of those configuration files, because we can lock this down and basically keep them out of it. When we install a virtual machine on their system, it's not going to look like just another folder in the on a Windows machine program files x86 folder, or on a Mac, it's not going to look like just another folder in the applications folder. We can make it look different. They won't know what it is. May not even be able to see it. And we, as the developers of this piece of software, have complete control over that configuration. So we don't have to worry about them deleting buttons that show up on our GUI, or images for buttons that show up on our GUI, or deleting configuration files or anything like that. That first problem I mentioned is still there, though. right? 3.7.9. Maybe we find a couple more bugs, and it's like, oh well, it's time to move this up. Look, I'll stick with the blue pen. 3.79's passed. So we fixed that patch, and there's a lot of updates, and maybe we decided it's time to go ahead and go to 3.8, and we add a couple features that they're not bugs, so they're not in the patch number, they're actual new features, so we're going to jump up to the next release, or maybe all the way up to version 4.0, and we're up to 3.8.0 for the release, which still requires us to send a notification or something to that user and say, oh, the software needs updated. Do you want to update it now? Because can we really trust them to click yes just because we fixed all the bugs in our software? Still a bit of a problem. So this VM, lightweight virtual machine, that's a container. That's what we're going to look at tonight. That's the modern way of dealing with it for that thing that's not really a release there. It gives us, as the developer, complete control over the configuration of that software. Because instead of installing our software and hoping their stuff's installed correctly, like that requirements.txt file we keep coming back to. Every time we install something with pip or Anaconda or any other installer for Python, it's going to look for the requirements.txt file, read all the modules that are listed in that file, and if it's not there, or we have anything in there that's not just the name of a Python module, it's going to crash. That is by design. There's no exception handling on that one. We don't have to do that on the end user's computer. We can do that on a virtual machine, and then we just install that virtual machine. Still depend on them for updates, and that's where this outer layer comes in for a CI/CD. We're going to talk about it next Monday. Continuous integration, continuous deployment. So no more version numbers. We'll say that. I'll put it this way because that's next. No, wait, no. Yeah, that's next week's subject. That's not next Monday. That's next Wednesday. Once we have our containers, we will, instead of creating an installer and occasionally sending that user notifications about an update, we'll put our software together and then create a continuous integration, continuous deployment thing so that every time this user goes and opens the software, instead of just opening from the local files like the old way where we just had those files in, or the containerized way, which is been popular for roughly a decade, maybe a little less than a decade now. It's been the most popular way to do this. Instead of just opening that virtual machine and running the software, they click the icon, and all the icon does is go over and look at the repository to see if there's a newer version. And if there is not a newer version, it opens the one that is already installed on their machine. And if there is a newer version, it downloads the newest version from the repository and opens that. So users never have to worry, or users never worry about it. We don't have to worry about that user not running updates and the software and bugs creeping into their thing or anything like that. All the icon does, the icon doesn't start the software. The icon checks the repository to see if they have the latest version. And if they do have the latest version, then it opens our software. And if they do not have the latest version, it downloads the latest version. So once we get to that point next Wednesday, we don't have to worry about whether or not the user is going to run updates after we fix bugs. We have complete control over the configuration of the virtual machine our software is running on, and we decide when those updates go out. Usually we set them, actually the one for our homework assignment, we'll set it to, the one in our homework assignment is, I think it's set to anytime we make a change to the main branch. So we can do all our work on side branches, and then when we merge that over into the main branch on the repository, the next time anybody tries to open our software, they get that newest version. Our homework assignment might also have a time in it too, so that it gets pushed out at like say 7:30 every day. We just push out the latest version. Whether we made changes or not, there's a new version. So that if somebody tries to open our software before 7:30 in the evening, I was looking at the clock when I picked that time, they get yesterday's version. And if they open it after 7:30 in the evening, they get today's version. And we just set up our pipeline that way. And that way we know they always have the latest update. We don't have to rely on users running the updates. Does that sound odd to anybody in here? So I'd be like, oh, that's strange. People would worry about that stuff, right? Because I could also pose the question, how many applications on your computer do that? How many applications on your computer actually have those files brought in and pasted on your computer versus how many applications on your computer check the repository to see if it's the latest version every single time? Probably don't know, right? That's my guess. So I don't keep track of it. I know that whole process, and I don't keep track of it. We don't necessarily keep track of it. We generally have no idea. I can give you a couple examples on mine. Earlier tonight, when we opened Spider, it asked if I wanted to update. So that means Spider is installed. A whole bunch of people in the class here said they were using VS Code for their IDE. Has VS Code ever asked you to update? To run updates? Have you ever got a message that says VS Code, there are new updates available for VS Code, you need to run those? I already know the answer to that. So it's continuous integration. Every time the developer makes an improvement, the next time you double click that icon, you get the latest version, you get the latest updates. Yeah, that's an example that I'm pretty sure is on most people's computers. But I can just about guarantee you that there's an example of each on your computer. But CI/CD pipelines have been the more popular way to do it for when did I'd say more popular in about 2020, late 2020, maybe early 2021 is when they really took off. They've been around for a little bit longer. The idea is nothing new. The idea has been around for a very long time. It's sort of the core idea behind the cloud. We're just talking individual pieces of software here instead of the cloud. That's a different class. So it's the core idea behind there. It's been around there, but I don't know, mid 2020, early 2021, somewhere around there, people suddenly became even more distrustful than they are naturally. I think everybody's already aware of that, right? You've met humans before in your life. Humans are a bit distrustful. And somewhere around that time, it really took off. That if we ask a user to install an update, they would jump on Facebook and just go on all sorts of rants. Lots of users would jump on Facebook and go on all sorts of rants about the things the government was demanding of them, even though software developers were not affiliated with the government that they're accusing of spying on them by asking for an update and demanding that they click on something. Right. Nobody in here is 4 years old, so I assume you remember that that little spiel in America. When that was going on, that's when CI/CD pipelines really, really took off. they've been popular for a while because it is generally a better way to do it. Because when we do it this way, a container open and we a container open through a CI/CD pipeline, the developer has complete control over the system. It's much, much better. So we need to do something. First step this week is Docker. And then after the Docker assignment, that's why it's next Wednesday. That way, if people are a day late or something, you'll hopefully have your Docker assignment finished by the time we get to the CI/CD pipelines. So I'm going to go over to a regular text editor to do this. I need to save that. I don't think that needs saving. So I'm just going to go to the regular text editor, and this one will be saved. So goes. In Sublime, but wherever you want to type your Python code, as long as we have a place to type. First thing we need is a Python program. So I'll go ahead and save this somewhere. Looks like I still have the repository. We downloaded that last week, so I'll make a new folder in here and label it as containers. So y'all can check the GitHub repository right after class, see the example. And we don't need anything fancy here. I'm just going to do a hello world. One thing that I am ask you to do is this week you are required to have at least one thing in the requirements.txt file because we're going to install modules on a brand new VM. Right? We're going to create a brand new virtual machine. So we will need to install Python, and then we will need to install some custom module. Emoji is a good one. Right? That's a nice, easy one, which is actually part of our language. So we should be using emoji anyway. PySpeak, we haven't seen PySpeak yet either, have we? That might. Oh wait. Let's not put PySpeak in there. So we'll look at PySpeak soon. Oh, that's a weird description. We'll look at that soon because our VM is going to be a Linux machine, and Mac and Windows have some really nice voices. So instead of putting words on the screen, we just want the words coming out of the speaker. It's a much better output. We could use PySpeak instead of print string. We'll look at that soon. It's great on Windows and Macs, but Linux does not have any good voices. It's back to the open source thing. The good voice models, right? The really high quality voice models have not done any volunteer work for open source projects. Microsoft and Apple were able to pay them the amount that the really good voice models wanted. So they have really good sound things, but the Linux one is still an old synthesizer. Like it would sound bad for like a early 2000s electronic voice. It's eSpeak. If you're on a Linux machine, install eSpeak, you can hear it. So probably that's the reason to watch out for the spoken ones. So let's go with emojis, and then we'll look at the voice output soon. TTS, text to speech. That's the one I wanted. I don't want PySpeech. I used PySpeech before. Import PyTTS text to speech. So instead of saying print hello world, we'd have say hello world. I like that module better than the one I pointed at the first time. Anyway, but Docker is going to be a Linux container, so we don't. Yeah, we don't want to. We don't want to hear the Linux voice. It's bad. I'll just put this in a function. Find word, find message, return emoji.emojize. Waving hand, same one we've seen before. Globe showing Americas, or it might be facing Americas, whatever that emoji is. It'll be very obvious if I got the name wrong. Then if name is main, our guard statement, then we'll print the results of that message function. So we don't need a complicated application here. You might want to do a little bit more. The requirement for your homework on the Docker assignment is that you do import at least one module. Because we imported a module, we better put that in our requirements.txt file. So let me create a new file, save that in the same place as requirements.txt. And if you do not import any modules, it needs to be exactly this. A couple people this week still put some words in there like didn't use anything, no modules used. This is a manifest file. A couple people were still putting things in there, but it's for an automated process with no exception handling. So if you don't have anything to add to the list, you want to make sure that it is just a blank file. It's just that name and then nothing written in it. Because we have some of those automated processes that by design crash if we don't follow those restrictions. And that's kind of our restrictions that we included that file created properly. So now I can open that, go to documents, /examples /containers. And I did not remember that. I was reading it off the line right above. So now we get to this folder, and then we can open PowerShell here, because the quickest way to grab the stuff for that file is to say pip freeze. That'll give us a list. If you have a virtual environment or a brand new clean installation of Python, the only thing on that list are what you use in your project, and then you can just echo this out in a file. Got a bunch of stuff on here, but somewhere there's an emoji library. There it is. So this software I just wrote depends on this library. Not going to work without it. So that's what goes in our manifest. We have to have requirements.txt. So that's, I think thus far, most of them have been blank unless somebody already knew about a good module that did the homework assignment better than the default module that the book actually wanted you to use. Because a couple of y'all have noticed by now that I am perfectly okay. If you know a good module that does it, if it gets the right results, that works. Yeah, usually. Things like the one I was grading this afternoon where it explicitly says make a generator function. If you didn't use the generator function, that's different. But if it just gives you, if it just wants a certain result, any way to get that result is fine. Should be able to test the software now. List it out so I can grab the name of it. Read.py, so I'll copy that and have the Python interpreter run that script. All right, there's our message. I remembered the name of the second emoji right this time. Waving hand is easy, but I often forget one of the words in the globe one there. It's like, all right, that software works. So nothing new there. We've seen all that before. But what we wanted now, we're at this time for installers. And we'll see installers soon. So we could either copy and paste these files onto the user's computer, in which case we'll need another script that would run the requirements.txt file, because at this point it's necessary in order. We need this file to install the emoji library on their computer in case they don't have it. At least check and see if they have it. If they don't, install it. So we need to run that. But instead of doing this, that's where Docker comes in. So I think it's already run. I'm going to go over to Docker desktop. We could do this all from the command prompt, which when you get ready to release things, you'd probably do it all in a script that is all and runs entirely in the background. But for ease of use in classroom, Docker desktop has has a graphical user interface. Makes it a little easier to work with. So Docker engine is paused. We want to make sure it's running. So we have several things. Really, we need to worry about these top two. So an image is what we put together. Has anybody ever done any like installing operating systems on a computer or install virtual machines? Image is like the instructions to create the virtual machine, and then a container is the virtual machine when it's up and running. So kind of like what we looked at last week, we do that specifically in programming. We had our class, which is the blueprint or design for an object, and then the object is when we actually use that class in our code. So same thing here. The images are a blueprint or a design, and then when we actually spin up a virtual machine from that design, that's a container. So I just installed this morning. Don't have any containers on here, but we'll see a list here that makes it nice and easy. And what we need before we get to that, I'm going to go ahead and close this because this never actually stops running. If I come down to the system tray, you'll see the little whale thing there. So Docker desktop is running. It's just not necessarily showing on the screen right now, which is usually what we want when we're using that in our software. We just need the instructions on how to make the virtual machine. So I'm going to create a new text file here. And this one has to have a very specific name. So save this as Docker file, a capital D, all jammed together as one word, and do not give it an extension. If you give it an extension, it will glitch out. It has to be that exact name with no file extension. So capital D, and do not put .txt at the end. Make sure that your text editor does not add .txt to the end. Some of them will. And do not use the Docker template in VS Code, because that has been modified and will only work if you build your container or launch your container from VS Code. It's really, really odd. It's not the only one, but if you install the plugin that pops up first in the list when you're looking for plugins for VS Code, the one first in the list was highly modified by people at Microsoft who made both VS Code. They renamed an open source project and claimed it as their own, and then they made Docker though. And the people that made Docker were allowed to customize the one that VS Code makes, but that will only work if you launch it from VS Code. So that will only work on your own computer. So don't use the Docker template and don't use the Docker file template in VS Code. Just hit the new file button and give it this name with no extension, because otherwise you can't use it anywhere else. really, really odd. Like, can't use it on GitHub next week when we build our CI/CD pipeline. So now we have this file. This is just a handful of instructions to build the file, build the virtual machine. So what's our starting point for the virtual machine? Well, our application needs Python. So let's start with a Python machine. So we use the keyword from, and the keywords are all in capital letters. And then there are lots and lots and lots of virtual machines that are already out there we can use. Docker Hub is the official one. Container image library. So this is where, when we say build it, it will go over to this repository, which is absolutely massive. Millions and millions and millions of starting points for us to use. We'll go to just a simple basic starting point. They get very, very refined. So we want to just use the basic Python starting point, in particular Python 3. We could add the 12, but Python 3 will be good. We didn't do anything that is specifically 12 that wouldn't be in 10. Or yeah, if you have 3.10 running on your machine, 3.9, 3.8, nothing that we did here would be explicit to 3.12, but this is our starting point. This is start the virtual machine and just use the basic Python 3 version virtual machine. And we need to set up a working directory. Where are we going to do stuff? And by the way, this is a Linux machine. So this line creates a Linux virtual machine, and we need a working directory on that. So first thing we'll do is say working directory, and this is on the working directory on the Linux machine. So right now, all these files are on the working directory on my Windows machine. So I need to copy them, get them over to a directory on that virtual machine. You just make up some name. If you know Linux or Mac, you could probably use some things that you used to, USR. But you can put it in any arbitrary place. I'll put it in an op folder. That way it looks somewhat familiar to people who know those. And just give it a name. Oh, payroll. Put it into a payroll calculator. Greeting. Payroll would be like a good example for your application where it's something more interesting than printing the words "Hello World." But this part will look exactly the same. Some sort of just a folder we're going to work in, and it is a Linux folder. So make sure the directory starts with a slash, not a drive name. What do we need to do? We need to copy. Yeah. So notice the Docker file is in the same folder as the script itself. So I'm going to say from the current directory on our machine slash greet.py. I could have left off that beginning part, but I want to do that for a reason. Copy it to the working directory. So notice there's two working directories on here. So copy from our machine to the virtual machine. And then obviously we could add folder names and file names if you want to rename it or something. But the multiple keep track of where the dot is, which one's our machine and which one's the virtual machine. So from our machine to the other one. Which also that it would work if we left that off because we're in the same directory. So I'm going to say current directory slash greet.py on our machine, just to this greeting directory on the other machine. We also need to copy over requirements. So from the current directory on our machine, copy over requirements.txt to the current directory so we can do stuff with them. Oh, well, now we're ready to start doing stuff because there's only one thing we really need to do before our software runs. Python's installed. We know Python's installed. So the only other thing we need to do is make sure that emoji library is installed. And then it won't crash when it hits line 3. So we'll have that virtual machine run pip install -r requirements .txt. And we've seen that in class a couple times. That goes through your manifest file. Pip install emoji 2.9.0 or other ones we've seen, Django. I'm obviously going to erase these. Flask, we saw that tonight. Colorama, I might have used a different module. Colorama's the one I normally go with, but for some reason I wanted to switch that. Oh yeah, because Colorama was already installed if you installed Spider. And that was like in week 2. Yeah, but we've seen a bunch of them. So it would pip install -r for recursive this text file. So install emoji 2.9, install Django, pip install Flask, pip install Colorama. So we're just going to read through that text file and install everything that's in that text file. That's why you don't want to have extra things in there. Well, now that we have Python installed, all the files our software needs copied over, and all the modules that we depend on installed, we're ready to actually start this. And same way we started over here, right? To run this, I go to that location and say, have the Python interpreter run greet.py. And we get our result. So that is our actual start command. So we need to put the start command into the Docker file, which uses a syntax that I don't care much for. So it's this line, but one of the common ways that we do that syntax is we pass in a list, and then each instruction followed by parameter is an element in the list. So, and then it will add the spaces in on the other side. So instead of just passing the string Python space greet.py, we have to type the command we want to run is a list, and the first element in the list is Python for the Python interpreter, and the next element is greet.py. So, well, in this case, this syntax is actually longer, but each parameter we need for the instruction gets passed in as an argument for the list. So to copy that pip one on the line above, I'm going to erase this line, but it would look something like pip, then the install word, then the -r string, then the requirements .txt file. So hopefully you can see a little bit clearer there. Each space delimited thing from that instruction just becomes an element in the list. It's a very common syntax. Personally, I would rather just pass that string in directly, but I didn't write Docker. So whoever wrote Docker decided to do this. Oh, well, that starts our software. So that's the last line we need there. All those lines make sense. And obviously that can grow very, very large because we have full control over a virtual machine that's running software on it. Can go a lot more for that, but this is what's required for your homework this week. So now we'll need this. We'll need Docker to build this. When you install Docker desktop, you should have got the instruction here. Notice there's no error message. I didn't tell it what to do. I probably should have put like -v or something so we could see it. But it's one of those, if you pass in Docker and then don't pass any of the required parameters to do stuff, it pulls up the help menu. So what do we need to do? We need to build an image. So I'm going to have Docker build from the current directory the parameter -t. I don't know who labeled these parameters, but -t, we'll see in a moment when it prints out as a table, stands for repository name. So T for repository name, we have to give it a name. Build from the current directory, so that dot's going to look through our current directory, try to find a Docker file, and carry out all the instructions in that Docker file we just wrote. And we need to create some sort of name for it. I'm going to call it hello there. And this one, it seems odd at this point when I'll try to explain why when we talk about CI/CD pipelines next week. But this has to be all lowercase, no spaces or dashes, no underscores or dashes, no spaces, underscores, dashes. So this name isn't the name the end user is going to use. This is a background name, and it has to be all lowercase alpha characters, not alphanumeric. So we want to build that image. And that's going to do this. So Docker is downloading all the stuff it needs, checking that. Here shortly, it's going to start doing, oh yeah. So notice all those SHA 256 encryption keys. So our software also has really, really good security in it now. If nothing else, if none of those other reasons from earlier, that's a great reason to use Docker right there, or use containers. Look at all those layers of security we have on our software now, as opposed to just copying and pasting these files over to the user's computer, which we will still see how to do that before long. Installers are still useful. It shouldn't take too long, and it caches everything. That's why when we set up our pipelines, it only takes it a second to check the repository. And when it compares against the repository, it doesn't have to pull down everything. It only has to pull down what has changed, the latest snapshot. Oh yeah, I probably should have built something else first, because this is the very first time since I installed Docker. So this takes a lot longer. So there's a lot of things that will be used on every single Docker image that have to be installed the first time. So they'll go quicker. But now notice that it's down to our instructions. All the downloading and encrypting and all that's done. And it's installing from that requirements file that's there. And we're back to the prompt. So it looks like everything worked. So a moment ago, it probably sounded like a lot when I said we were going to put our software in a VM that only runs our software, but everything's set up for us. So it's really just the Docker file and then that instruction, which when we get to the CI/CD pipeline, GitHub gives us the instruction on the copy button. So we don't even have to even put all the effort, so much effort as typing it. We'll see that next Wednesday. Now that we have that, we can say Docker -a images, I think. This felt wrong one. Nope, that's not it. Oh. Docker images -a. Whoops. That's not it. Ah, there we go. That's the one I wanted. Docker images, so all of the instructions we have to create containers from, -a is all for the list. And you'll notice in the repository name column, there's that -t parameter. It also has an ID. So now we can use either one of those to run that. And Docker Desktop has a GUI. I prefer for you to do those couple of lines in there, but if I come over here, you see we have that image made now. So it's showing all of that. But it's just a couple lines. And since in general, you will probably do this in the background, you probably want to practice those lines to get some practice doing that before you do it in the job setting. Now we can run that. So Docker run. Oh, I remember why I was going to do a payroll example and then drift it off. If you need the terminal to interactive terminal, -ti is interactive terminal. I do not need that just to print a statement. But if you want input, that will take your that will make the interactive terminal. So you'll typing stuff in PowerShell or Bash or Zeesh or CMD, whichever terminal you use, it becomes interactive and passes directly through to the Docker terminal. So probably want that. We did some stuff in Django. We've already seen Django, so we might want port 80, 8080 or 8000. Sorry, Django, not Spring. So -p for port. We might want to map port 8000 on our computer maps to port 8000 on the virtual machine. We'll see that. We'll see that later in an example where we actually throw a Django app into a Docker thing if we don't run out of time in module 8. But we can map our terminal or port numbers to the virtual machine so that it still behaves entirely like ours. So you probably want -ti for interactive terminal. And we want to run, the name will work. So if I copy that, paste that in there. Did I forget something? Oh, there it is. Okay, took a long time that first time. I'm gonna clear that in. Actually, I don't want to clear it. So we can use that repository name, but when we get to CI/CD pipelines, that repository name is going to have a URL, which is hard to keep track of because it's going to be dynamic URL that changes to the version. So we can choose Monday's version or Tuesday's version or last Thursday's version. So it's a lot better to go with the ID, which you'll notice this is just a table. This is just a two-dimensional list. So if we put that in a string, it's index 0, 1, 2, 0, 1. So a two-dimensional array index 0, 0, or sorry, 1, 0, 1, 2, 1, index 1, 2, 2, 1. Sorry, count over. Rows first. So 0, 1, 2. Our first index is 2. And then we want the first element in that column. So 2, 1 is the most recent image. That's what we'll use when we get to our CI/CD pipeline. But if we do Docker run -ti for interactive terminal in that ID, we'll get the same thing. Oh, apparently it didn't use the cache version. I was expecting it to be quicker, so it's finding it necessary to start Docker for some reason, spin things up, and completely rebuild the machine every time. Usually it just builds the machine the first time. I'm not sure what setting I might have modified. There it goes. That took a while. Okay, yeah, it's rebuilding it every time. It's normally really quick. It caches everything, but for some reason, um, I have no idea why it didn't cache that and had to recreate the machine from scratch for some reason. But then that's the instruction to run. So there's only 3 instructions, right? After we get the Docker file, we do Docker build dot from the current directory -t for because we're required to enter a repository name and something. So we do that, and then we do. Actually, we don't even need to really list those others out. Dash run with an interactive terminal, or maybe take the port number or on Django and map port 8000 on our computer to port 8000 on the virtual machine, and then something. Then that name we just gave it. So really, it's just those 2 lines. Let's look at Docker desktop here. Let me show you how to clear these out. So notice now we have the 1 image and we should have 1 container. Might have a couple containers. Oh, yep. Those are all built from the same machine. So that's what that delay was. That I must have changed the setting somewhere, because it really should have recognized that I was building from the same image as last time. It just opened the previous one, which happens really quick, obviously, as opposed to making a new virtual machine from scratch. But we have those 3 containers. And if it's not behind the Zoom thumbnails on your screen, there's a delete button over here. So we need to delete those, but order matters. If I come over to images, right, the instructions on how to build the virtual machine and hit the delete button, delete it, and we get this message that says a container is using this. So order matters. Think of objects and classes, right, in Python, right? We can't delete an object. We can't delete the design for an object if there's any of those objects around. So you have to delete the containers first, and then you can delete the images. And that's the basic idea of the Docker stuff. Make sure you import modules for whatever you do. I'll let you choose that. Some input's nice, so a payroll calculator or a tip calculator, those are nice, simple ones. Some small, something small, it doesn't have to be much because the focus is the Docker file, creating the Docker image for it. Hope the steps, the instructions should be spelled out, and then you'll decide what the Python is, and just make sure you import at least 1 module so that there's something in the requirements.txt file. I guess now I can push this back to GitHub. Git add dot stage all the files. I did that. Now they're added. Git commit. Intro to Docker. Give it some sort of name so we can identify this particular commit. I'm doing this in a way that hopefully there's no errors, because that's flashing by too quick to read any error messages on that screen. And now that that's committed, can say git push origin name. This one will take a little bit longer. I didn't see any error messages, so those files should be there if you want to refer to them. If you were following along our example here, that's what the homework assignment is. I spelled those steps. I wrote those steps out in the instructions. So you can basically see those same instructions. The only thing that's going to change is you choose what the application is going to be. Just make sure you import one module so that the requirements.txt is not blank. Anybody have any questions about that?
That was for the next week's module, correct?
No, that's in this week's. This week is Docker, and then next week we'll do the CI/CD pipeline. So, oh wait, what do you mean by next week, Nathan? It's not due by midnight tonight. It's due next Monday. Is that what you meant?
Sorry, the module 5.
Yes. So it's in module 5, which
Yeah, the module 5 stuff. Yeah, that was what I was meaning.
Yes, not due at midnight. This week isn't due next
All right, thank you.
Monday. So not and then the following module we'll do a pipeline with that. So please make sure you get that one done because the next step, the following week's assignment requires that to be done. Either that or you have to build a new one for the following week's module. Fairly straightforward. If you were following along the example there, then you have the homework done. Just upload that to GitHub, send me the URL like normal, and that's one assignment knocked off the list already. Otherwise, those steps are spelled out in the instructions. If you have any questions about it, let me know. Just introducing Docker, containers do get large, and Docker is not our only container. Let's do a quick search on that before we wrap up here. We'll be doing Docker. Docker is the one Microsoft's design, and it is by far the easiest to use and the easiest to get started with. But if we search for alternatives to Docker, we should see some nice list. 11 best Docker alternatives. What's on here? This looks up. Build it, kind of nice. Very, very similar. A little bit more control over it. Which it is basically a Linux daemon. So that's what we're building, and this extends across platform. Oh, Vagrant's awesome. Vagrant's the top tier one. But it's the top tier one. It's the one we have the absolute most control and can do the most with, but there's a massive, massive learning curve. So using Vagrant wouldn't be one lesson, that would be a whole class. Containerizing, it's simple to use. 0 VM. I think I've tried that once, but I can't remember anything about 0 VM. Podman, build kit. There's a lot of things. Oh, Runsby, is that? Oh, Podnate. Okay, he's pretty nice. Azure containers. Kubernetes. Those are Kubernetes is an incredibly popular container. Way to containerize things. Oh, 0, that might be. Let me look at that 0. Okay, yeah, this is Chromium native. So this is the one that we would use for. I don't know if anybody knows the details of. So Google's operating systems, Android and Chrome OS, those are actually Linux networks, and every application is treated as a user. That's why it's easier to write Android apps, because our Android apps are allowed to use other apps just like we are. So if you needed to grab something from the internet on iOS, you'd have to bring in browser functionality to your app. But on Android, your app can just use the normal browser on your Android system. Same thing with Chrome OS. And in order to set it up that way, they all have to be containers. So 0 is what is used to build the containers for Chrome OS applications. So if you there's multiple ways to do it, but if you want to do it the official way, proper way to get your stuff on your application on a Chromebook, you would use 0 VM and then make that way your application just becomes a user on the Chrome OS network. But you can see there's lots of containers out there. I just happened to explain at the end how one of the very, very common operating systems is built entirely depending on expecting everything to be a container. So definitely something you want to get some practice with. Docker is the easiest way to do that. It's been a few seconds since I asked if anybody had questions. I'll give it like 3 more seconds so you have time to unmute. Okay, I assume silence means no questions. If you have any, let me know. Otherwise, that was it for today. Wrapping up a little bit earlier. And then, like I said at the beginning, there might have been some people coming afterwards. Next Monday is the night that is going to be long, so we probably will be here till 9:30 next Monday. It'll be a 2-break kind of day, though lately I found that on the really long ones, people seem to respond better to 3 breaks. I will probably ask about that Wednesday. We'll do a poll or something where it's a 10-minute break, and then instead of another 10-minute break, we take 2 5-minute breaks later. Because, yeah, we've got a lot of stuff to go over Wednesday and Monday. So next Monday looks like the night that we will be here pretty much the whole time that's on the schedule, which is a really long class. But otherwise, I'll see you all Wednesday, and y'all have a great night. We'll get started in data.